Let's do example 8, question 1. We have vector m, which is I minus j minus k, which is actually just vector om. So just imagine we have the coordinate origin and the coordinate m. Therefore, the coordinate here will be om or vector m. And if I also have coordinate n, the second vector will be on or vector n, which is this one. So for part A, we need to find a vector that is perpendicular to vector m and vector n. So just look at vector m first. I want to have a vector that is 90 degree to this vector, So 90 degree can mean two things. It's either 90 degree going upward or 90 degree going downward. So this is for vector m. And we also need a vector that is perpendicular to vector n as well. So this is vector n. And I want a vector that is 90 degree to this vector. So it can be 2 as well, which goes upward or goes downward. So this means that actually I need a vector that is perpendicular to both of these vectors. And to do that, we must apply the vector product. Because if you do n cross m, which starts from n going towards m, or you can use the letter D. So if you go anti-clockwise, we go upward, which is this one. Or we can also do m cross with vector n. And this one is clockwise rotation. So we'll be using the letter P. So if we go clockwise, it will go downward. So this is for m cross n. However, for this question, we only want one vector only that is perpendicular to these vectors. So you need to choose either you want to do n cross m or m cross n. So there are actually two answers here. So let's say I want to do n cross m. So we're going to do the determinant for 3 by 3. The first row is always I, j, and k. For the second row is always our first vector n, which is this one. And for the third row, we need the second vector, which is this one. Don't forget, for I, we need to put plus sign, minus for j, and plus sign for k. And for the calculation, we're going to do determinant I, determinant for j, and determinant for k. I is positive, j is negative, k is positive. I is positive, j is negative, k is positive. So let's do for I first. So we're going to close the first and the second row. So we're going to copy down everything here. For j, we're going to close the first row and the second column. So we're going to copy everything here inside here. And lastly, for k, we're going to close first row, third column. So we're going to copy down everything here inside here. Next, we're going to exchange this determinant to become bracket by doing the calculation. For the rest, we're just going to copy it down again, which is plus I minus j plus k. For the first determinant, it's going to be negative 1 minus 1. For the second determinant, it's going to be negative 2 minus negative 1. And for the third determinant, it's going to be negative 2 minus 1. So now we're going to simplify everything here. And the answer is this. So this is the answer if you do n cross m. But if you do the other way around, which is m cross n, you'll get the answer is 2i minus j plus 3k. So as you can see, it's almost the same as n cross m. This is because these two vectors are actually opposite vector. So as you know, if you have opposite vectors, which is a and negative a, this means that when it is in opposite direction, the vector will have negative sign to indicate the change in direction. So this means that m cross n is actually negative times n cross m, because this vector is the opposite direction of n cross m. For part B, we need to prove that this vector, which is the vector that we found just now, which is n cross m, it is perpendicular or 90 degree to the vector m by using the scalar product. So we know that by using scalar product, if your theta is 90 degree, your a dot b should equal to 0. So this is what we're gonna do. So in this case, we're gonna do n cross m dot with vector m. Therefore, we can make the conclusion that since the scalar product of this vector and m is 0, therefore the vectors n cross m and the vector m are perpendicular. And we can see from the sketch itself that this vector n cross m is actually 90 degree to our vector m.